Hi everyone, welcome to this new episode of Jpreneur. Today I'm going to be talking about how I'm going to pursue a master's in software engineering at the University of Waterloo in Canada. So about 3 months ago, I received an email and it said, University of Waterloo Graduate Studies. And so when I opened it up, the first thing I saw was this message you can see here on the screen that says, University of Waterloo, you're in. And so I thought, oh, this is great. I'm so happy that I got into into my top choice for school. I thought this is great, but I also thought I was being accepted into the systems design engineering program, which was kind of like my second choice, because I didn't have an electrical and computer engineering background or a software background. I came from aerospace engineering, but this was not something I was very familiar with, but I still really wanted to pursue this master's. So when I started scrolling down and I saw that I had been offered admission to the electrical and computer engineering program at the university, I was, so excited I couldn't even believe it. And so I didn't even think about the other offers I had from other schools. I just accepted this one, and I was like, I'm gonna close this deal right now because this is amazing. So, I think today I'm gonna be walking you through how this program works. There's tons of options to choose from in the electrical and computer engineering program. And more specifically, I'm going to be pursuing software engineering, and I'm going to be showing what classes I'm going to take and hopefully how that can relate to creating startups and becoming a better entrepreneur. So with that being said, let me go here to the program. So by the way, it starts January 2021. So two months from now, almost 2 months from now. So let me see. Okay, there we go. Yeah, so this is the program. It basically lasts 4 Canadian terms, or in other words, about a year and a half, a year and 4 months to be exact. And there's all of these graduate specializations you can choose from. So this is actually a pretty broad program because it covers, both electrical and computer engineering. And so the specializations available are artificial intelligence and machine learning, one option that I really considered, and I think it's a good one, but then I'm going to show why I'm not going to pursue this one, and I'm going to pursue software engineering instead. So then you have biomedical engineering, computer networking and security, nanoelectric circuits and systems, nanoelectric devices and materials, software, and sustainable energy. So let's see. So here's the admission requirements. I think I've already talked about the requirements in a prior video, but just to do a recap, you basically need to have a 75% overall if you're an international in your bachelor's degree. So what you study as undergraduate. If you come from outside of Canada, you also need a resume. You need to complete another form where they just ask some questions, and you also need to show your transcripts. You also need to show 2 references where at least one has to be academic. In this case, I talked to 2 of my professors from Purdue University, and they gave me the references. So thanks to them. In case they watch this video one day, I'm not going to mention specific names, but they know who they are. And then here you also need an English language proficiency. I think, obviously you would have to look at the specific requirements, but in general, if you come from an English-speaking country or you studied at an English, so if you studied at a university where the main language of instruction was English, then you probably don't need to take a test. So let's see. So these are all of the courses. Basically, the way this works is that you have to take 8 courses to successfully graduate. For people coming from undergrad, that doesn't might not seem like much, but this is master's level, so it's a lot harder than undergrad, and also it's packed in a year and 4 months, so something to consider when you're thinking about the workload. Let's see. So I think another important piece of information is that you can take 2 classes like as minimum and 3 classes as maximum. So you can complete this program in a year if you take 3, 3, and 2, or 2, 3, and 3, and so on, in any combination you want. But I'm gonna spread it out in 4 terms, or a year and 4 months, because that extends your post graduation work permit. So then you can stay for longer, working in Canada, and hopefully after that, you might be able to get permanent residency in the country. So that's mainly the reason why I chose to do a master's degree. Not only because I wanted to really learn about software, but also because I wanted to live in Canada and build companies there. So I thought, the best way for them to consider you as an immigrant is if you have qualifications. So, even though it's a big financial investment, I think it's a smart decision for me to go to Canada and be able to hopefully study and get qualified and get my permanent residency. Because right now the whole immigration landscape in the U.S. is a little bit tense and complicated. So I just prefer to consider Canada as a potential country to live in. Okay, so that being said, these are all the specializations, right? So we're going to go one by one. So first of all, we have artificial intelligence and machine learning. This was actually the one I really wanted to pursue, but let me explain why I'm not going to follow this one. So you have to take 2 compulsory courses, which are like the required ones. So tools of intelligence, systems design, and data knowledge modeling analysis, right? And then you can choose from all of these electives. So intro to optimization, this is like a math class. Statistical signal processing, I've taken similar classes in undergrad. I don't think it's, I don't really like this class that much. It's just, signal processing with statistics. I mean, I enjoy signals, but I just think it's not that relevant in my opinion. Then you have algorithm design and analysis. This might be interesting. Fundamentals of ultrasonics. I don't really care about that. Image processing and visual communication. This one I like it. Intelligent sensors and sensor networks. That's another one I really like. And then all of these ones here, which are like applied topics. And so basically you need to take 5 out of these classes to get a graduate specialization in your electrical and computer engineering degree. So then we have biomedical engineering. So basically you can take, foundations of biology, quantitative methods in BME, engineering analysis of living cells, very, biological stuff. And then you can also take some of the classes above, and then you have other more specific topics related to biomedical engineering. I have zero background here, so, I don't really know a lot about biology. I don't come from a biomedical or bioengineering background, so this is not applicable for me. So computer networking and security. I also don't really like networking and security that much, but if you're interested, you can take a look. But basically, you have a bunch of communications and protocols classes and computer networks, and a lot more about information theory, and then wireless communication. So this is a lot more with kind of like communication infrastructure. So probably if you want to be a telecommunications engineer, this might be a good one to take. Then you have nanoelectronic circuits and systems. This is more for people who come from a really hardcore like nanoelectronics or electronics engineering or electrical engineering, or maybe physics. So this is more kind of like nanophysics and a lot of electronics. So you have, let's see, so semiconductors, microelectronics, circuits, IC design and radio frequency, microwaves, and you have like sensors, let's see, communications, radio systems. So this is really more of a hardware master's, that's our specialization. So I am not specifically interested in hardware or electronics, but I feel like this is also a really good option if you're thinking about hardware specifically. Then you have nanoelectronic devices and materials. My guess is that this is more on the physics side and more like research side of hardware. So there's semiconductor devices, technology, photovoltaic conversion, organic electronics, optoelectronic devices. Um, all of the things are really good, but um, just very applied, let's say. And so this is, if you have a really an interest in this topic, then that's good. So finally, we got to the one I really want to do, which is a graduate specialization in software engineering. So we have all of these classes. So first, we have methods and tools for software engineering. I'm going to be focusing or zooming into these classes specifically. I have a list of what every single class is, and I'm gonna show you the link to where you can go to see every single class specifically if you're interested in these topics. So first we have methods and tools for software engineering. That this is basically an introduction. So you go through databases, queries, programming languages, operating systems. It's kind of like the basis or the introductory course. Then you take foundations of software engineering. So this is more how to structure a software project and other things. Then you have software testing, quality assurance, and maintenance. So this is more like, okay, once I write software, how do I make sure that once I deploy that software, nothing's going to go wrong? So it's just testing and making sure that things work. Very important, especially in large projects. And then these are all of the electives, right? So remember that to graduate, you need 8 classes, and you can take 5 classes you have to take 5 classes to get your specialization. So the elective courses, we have algorithm design and analysis. So this is how do you create a robust algorithm that works efficiently. Then you have protocol software and issues in mobile systems. This is also an important one because this is everything related to mobile, so smartphones and probably like IoT devices or things that connect to the internet that are small. And you have database systems, so it's pretty self-explanatory, but just how to code and create and work with databases and storing information. And you have tools of intelligent systems design. I don't really remember what this class was about, but it seems very interesting. And then we have component-based software. So this is how do you reuse, recycle software to reduce costs and be more efficient when working on large projects. Then we have finally graduate specialization in sustainable energy. So you can see that all of these different branches are just very different to one another. First, we have so this is more like sustainable energy if you want to work for, let's say, a solar panel company or maybe Tesla or a company like that where sustainable energy is very appreciated. In Europe, there's a lot of sustainability projects too. So this is also something that's in really high demand. I mean, all of the specializations you've seen now are largely required in the job market, but this one has to do more with energy, so energy processing, high voltage systems, power analysis, power components, high voltage engineering, sustainable distributed power, dielectric materials. So this is more like electricity and how to create sort of efficient energy systems. Interesting, but it's just not sort of where I come from. So yeah, those are all of these specializations. You can take a look at the courses if you go here. So you just go UWaterloo and you go Masters of Engineering in Electrical and Computer Engineering. It will take you to this website. You have a lot more information about everything here. But if you scroll all the way down, you just go here onto the Electrical and Computer Engineering courses, and you can see that there might be courses that are not included there. But here's like the full list of courses that are offered, so you can sort of tailor your own program according to your needs. I mean, if you have an interest in 2 fields or more, you can say, I'm going to pursue a specialization in computer networking, but I would also like to take classes, or at least some classes in sustainable energy. Then you can do that too. Okay, so let's see. So now I'm going to explain why I chose software rather than AI. So first of all, there's a big overlap between the two. Why? Well, because if you take a close look, you have let's see. So if we take a look at the classes, we have tools of intelligent systems design, algorithm design and analysis, and let's see where those are here. So tools of intelligent systems design, same class. Algorithm design and analysis, that's another class. So two already overlap, right? Okay, and then out of the ones I'm interested in out of here, those were data, knowledge modeling, and analysis. It's important to work with data, know how to visualize it. I do come from an economics background, so I've already worked with lots of data. I don't think, I mean, if I had the chance to take this, I would, but I think there's other more relevant or more important classes that I want to pursue, even though this is really important. Um, let's see. Then we also have, this classes I'm just not really interested in at all. The ones I was interested in were image processing and visual communication. I'm really interested in, vision, computer vision, how that applies to AI and those topics, and also intelligent sensors and sensor networks. So how to work with the Internet of Things and connected devices. So these are the two that I really wanted to pursue, as well as tools of intelligent systems design, but that's already included in the software engineering program. So if we scroll down again to the specialization in software engineering, I feel like it's very hard to work with artificial intelligence if you don't have a background in like databases and software engineering as like the main concepts. And since I don't come from a computer science background, I just thought it would be good to take this graduate specialization to go through all of the foundations and then learn those things while complementing my, let's say, my studies with classes that come from the artificial intelligence program. So basically, these three classes I'm gonna have to take them. I think the three of them are very important. And then I think out of these ones, I chose to take all of this four. So that would make a total of 4 and 3. That's 7. And then basically to that, I would add this two that I already mentioned here, which were intelligent sensors and image processing. So I can kind of like get the best of both worlds and just really have a very complete program. So even though it says you need to take 8 courses to graduate, if you take, let's say, an additional course, you can do that as long as you graduate in 4 terms or a year and 4 months. So basically, there are 3 terms per year. Each term is 4 months. At least this is how it works in Canada. And so basically, if I take let me think. So if I take 2 classes the first semester or first term, 2 classes the second term, then 3 classes during the third term, and then 2 classes during the fourth term, I would take 9 classes total, but I would graduate with at least 8 by the fourth term. So that's how you can take, instead of taking 8, you can take 9 by just fixing the schedule or the plan of studies. And so I don't know if you guys have any other questions. I mean, if you're really interested in this, you can just write a comment below and about this program in general, or maybe just contact the graduate admissions office. They're super friendly and they'll be able to respond to anything you ask for. And so okay. So now I'm going to show. Let's see. I don't remember how I saved this file. There we go. So I actually created a list here of the classes that I plan to take and how this will sort of help me in understanding things one by one. Now I'm just going to do kind of like a general overview, but once I start masters, I'm going to be talking about what are the topics that I'm learning and what that's applicable for and how you can, or how I'm going to be able to use that in my life. So First, we have image processing and visual communications. So this is one of the main classes I'm interested in. So this covers the concepts and methods and theories for image processing and visual communications. Well, it's pretty obvious. So things that are included are digital image and video processing, image analysis and understanding, statistical image modeling and perception, and robustness, scalability, and security issues in visual communications. So this is kind of like processing and working with images. I feel this is very important. There's a lot of computer vision stuff going on with artificial intelligence, and more specifically, convolutional neural networks. That's kind of like a deep topic to know, but just keep in mind that this is a super important thing for facial recognition and just dealing with images as a whole. So then we have one of the foundational classes, or the first one, or the introductory one, let's say. So this has to do with programming and operating systems, scripting, systems calls, libraries, compilers, and interpreters. It also includes, mathematical logic, propositional predicate logic, and also syntax, entailment, deduction, use of logic. You have data structures, so lists, tags, queues, heaps, trees, graphs, and algorithms. So this is kind of like the introduction to how computers work and how software is developed. Then we have foundations of software engineering. So basically, the fundamentals of software requirement analysis. So if a company or a client comes and says, or if you're building a company and you have a requirement like, I need to build software for a car that needs to be autonomous and whatnot, you just learn how to analyze those requirements and how to tailor the resources that you need to that specific project. So then you have software development as an engineering activity, basic process models, so software specifications, modularity, cohesion, coupling, encapsulation, information hiding, principles of object-oriented design, software project management, quality assurance and controls. You also have a bit of software architecture, so styles and communications between components. You also have, languages for software design, so class diagrams, sequence diagrams. This is more like how you handle projects by like showing those diagrams to perform tasks and build code. Verification and validation, maintenance, re-engineering. Then you have software metrics, quality assurance, cost and effort predictions models, and then trends in software engineering. So Scrum, Agile, design thinking, all these new approaches, which have to do with like how you approach the whole steps from the idea all the way to deploying the software and maintaining it. So very interesting. This is a class that covers a lot of things. So it's probably going to be really, really hard, but also it kind of gives you the whole panoramic view of everything you need to take. Then we have software testing and quality assurance and maintenance. This is the last required class for the specialization or compulsory course. So you have to take testing of software systems, verification, reviews, metrics, quality assurance, reliability and availability, and you're expected to have programming experience with reading and writing code for large projects. So I have already worked with large projects. For example, when I was an intern at Bombardier Aerospace, I had to translate code from P-Wave, which is based in Fortran, to MATLAB. I had to really just work with huge files and libraries and just go through all of those documents. I already have experience with that. I am currently also taking courses in Udemy. That's going to come in later videos. I'm going to show how, even though these are not huge projects, there's still a considerable amount of code to keep track of, and hopefully keep on building a portfolio to be able to already have those projects when I take this class. But this is probably going to come with the third term or so. Okay, so then we have protocols, software, and issues in mobile systems. Basically, this is concerned with architecture, protocol, and software aspects of mobile systems. So again, you have sort of, let's say, not static systems, but non-mobile systems, let's put it that way. So kind of like a computer is not that mobile, but a smartphone, or let's say a Fitbit or a smartwatch, that could be a mobile system. And then, you need to know mobile communication and computing, supporting the networks, sort of the wireless protocols, mobility. So, for example, if you have a plane or car that connects to the internet. Um, what else? You have environment aware software and low power protocols and software. So this is basically if you're prototyping an IoT system with low power, like an Arduino or something. I'm sorry that I'm getting super technical. Again, if you need clarification on something, let me know and I'll explain more um, in a later video. So this is just for everything that's mobile. So super interesting. This is one of the classes I'm probably going to enjoy the most. I'm super interested in this topic. Again, I've worked with satellite systems before. So even though I haven't specifically done this, I know that I really like everything that has to do with communication and systems that connect to the internet and move. Or that are, part of a network. Okay, so then we have database systems. So even though this is kind of like the most boring topic I could think of, it's very important because you need to know data models, file systems, architectures, query languages, integrity and security, and database design. So it says you should have a 4A level electrical engineering or computer engineering background. I do not have this, but it says should and not must, so I'm still going to take it. I'm going to try to learn a bit more about databases before taking this class, just to have a concept, because otherwise it's going to be way too raw to get into the class without knowing anything. So that's why it's also going to be pushed to the later terms of my master's. And then finally, and another very, actually, never mind. So here we have tools of intelligent systems design. So basically, how to tackle complex systems, under functionalities and operating environment. So it says when there are ill-defined processes and you might have, an unpredictable environment or noisy environment, then you need other more powerful techniques. Very helpful when you do AI. So here it says recent developments in the areas of intelligent systems and soft computing have presented powerful alternatives for dealing with the behavior of this. And so basically what we're going to learn is soft computing with approximate reasoning, fuzzy interferencing, and neural networks, as well as evolution algorithms and neurofuzzy systems. So all of this is more like the AI, kind of like how smart systems work. And then you have, let's see, like applications of this kind of technology, such as pattern recognition, system planning, classification, power generation, intelligent transportation, systems and control, mechatronics, optimization, communication, robotics and manufacturing, etc. So as you can see, the great thing about software and software engineering is that it can apply to so many different fields. As I mentioned in the past video, everything needs software and all startups need software. And so it's a great thing. You can just, learn this stuff and apply it to everything. Okay. Then we have intelligent sensors. People are just scheduling meetings. Okay. So intelligent sensors and wireless sensor networks. This is has to do more with the communication side of things. So this is concerned with sort of IoT devices. So you will cover basically designing and analyzing intelligent sensors and sensor networks, mobile and stationary, with emphasis on mission critical applications. Very interesting. This is a class I'm really going to like. So everything that has to do with the Internet of Things. Finally, and this is a class I think I'm also going to enjoy, this is how to build large-scale and complex software from available parts with increasing return on investment, decreasing time to market, and assuring quality and reliability. So this is more the project management side. This is what I'm really interested in, like how to understand software as a system and how to use that to increase ROI and be more efficient. And and so this course basically just covers software components and topics that are related to component-based software engineering from research and practice. So those are all of the courses that I'm going to take. or that I plan to take at least for now. So as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And so it's super robust course covering a lot on hardware, because there's a lot of communication and IoT and sensors and vision, but also a lot on the foundations of software, as well as sort of the agile approaches and software project management, and how to make sure that everything is reliable and has a good return on investment. So I thought this program was excellent, covers a lot of things. I am very interested in doing this, and so I'm going to be posting more content on what are the things that I'm learning and how it works, and hopefully someone can just take all of this information and my own experiences for their own personal benefit. I feel like it would be great if I could actually find something this complete online. I just couldn't really find anything where people explain step by step what they took and how they took it and what it was about, whether they liked it or not, and if taking the class is really as good as it looks on paper. Because sometimes professors just include all these buzzwords such as AI and vision and whatever, and then when you take the class, it's all like math and super boring. So hopefully that's not going to be the case, but I'm going to be posting more content to let you know if that is the case or not. So thank you very much. That's all I have for today. Later on, I'm going to be talking about the courses that I'm taking on Udemy and how those are helping me to improve my software skills, and what are the different things. This is more on the theory side and what you take in school, but there's also a practical side to it where there's like different languages and different tools to build apps and websites and stuff that are not really included in this program, because this is more like software engineering and not really like web development or anything else. So it's always good to complement your skills with the theory, but also the practice, right? You want to be a good engineer, you need to know all of the foundations and the theories and the basis to know where to find the resources that you need, but you also need to apply those concepts in practice, and because otherwise there's no correlation between theory and practice, and you're just not going to be effective as an engineer. So thank you very much. I hope you really enjoyed this video, and please subscribe to the channel if you feel like doing so, or ask any questions you may have. So thank you very much.